Hey everyone, and welcome back to the channel. Today, we're re-diving into one of the most fascinating and slightly mind-bending topics in artificial intelligence, emergent abilities. What are they? And why are they getting so much attention? Let's break it down. Imagine you're teaching a child basic arithmetic. You teach them addition, subtraction, multiplication, and division. You test them on these skills, and they do great. But then, one day, completely unprompted, they start solving complex algebra problems. You never taught them algebra. They just figured it out. That unexpected leap in capability is, in essence, an emergent ability in AI. In the world of large language models, or LLMs, like the ones powering many of the AI tools we use today, emergent abilities are skills that suddenly appear as the model gets bigger and is trained on more data. These aren't abilities that were explicitly programmed in. Instead, they seem to emerge once the model crosses a certain threshold of scale and complexity. Think of it like water turning into ice. As you lower the temperature of water, it just gets colder and colder. Nothing dramatic happens for a while. But then, at exactly 0 degrees Celsius, it undergoes a phase transition and suddenly becomes a solid. The properties change dramatically. Similarly, as AI models grow, their performance on many tasks improves predictably. But for some complex tasks, performance is basically 0 for smaller models, and then, bam, once the model reaches a certain size, it suddenly becomes remarkably good at it. So what kind of abilities are we talking about? It's a huge range. One classic example is multi-step arithmetic. Smaller models might be able to add 2 numbers, but they'll fail at a problem that requires several steps. Then, a larger version of the same model architecture can suddenly solve it perfectly. Other emergent abilities include things like generating computer code, answering abstract questions, identifying the intended meaning of a word in a sentence, or even showing signs of what we might call chain-of-thought reasoning, where the model breaks down a problem into smaller, logical steps before giving a final answer. Researchers at places like Google and Stanford have been studying this phenomenon intensely. They've found that for many complex tasks, there's a clear breakthrough point. Before this point, the AI is no better than random guessing. After this point, its accuracy shoots up dramatically. It's not a slow, gradual improvement. It's a sudden, almost magical leap. Now, this raises a huge question. How does this happen? The honest answer is, we don't fully know yet. It's an active area of research. The leading theory is that as these models become incredibly large, they develop more complex and abstract internal representations of the information they've learned. These rich representations then allow them to combine concepts in novel ways to solve problems they weren't explicitly trained for. It is like having a vast library of knowledge and suddenly realizing you can connect ideas from different books to form a brand new theory. The implications of this are massive. On one hand, it's incredibly exciting. It suggests that by simply scaling up our current AI models, we might unlock even more powerful and unforeseen capabilities that could help us solve some of the world's biggest challenges, from discovering new medicines to creating new forms of art. But on the other hand, it also introduces a profound sense of unpredictability. If we don't fully understand why these abilities emerge, it becomes harder to predict what future, even larger models might be capable of. This is a key reason why AI safety and alignment research is so critical. We need to ensure that as these systems become more powerful, their goals remain aligned with human values. We want to be able to anticipate and guide these emergent skills for good. So, the next time you interact with a sophisticated AI and it surprises you with its cleverness, you're likely witnessing an emergent ability in action. It is a sign that we're moving from simply programming computers to creating systems that can, in a way, learn to learn. It's a wild, unpredictable, and exciting frontier. What do you think about emergent abilities? Does it excite you or make you a bit nervous? Let me know your thoughts down in the comments. Thanks so much for watching, and if you enjoyed this deep dive, make sure to hit that subscribe button for more content on AI and technology. I'll see you in the next one. Have you ever taught a kid how to add numbers, and then suddenly, they figure out subtraction on their own? It's like a little spark of magic, right? Well, something similar, but on a cosmic scale, is happening right now in the world of artificial intelligence. It's called emergent abilities, and it's one of the most fascinating and mind-bending topics in tech today. So, what exactly are emergent abilities? Imagine you're training an AI model. You feed it a massive amount of text from the internet, and your goal is simple. You just want it to get really good at predicting the next word in a sentence. You're not teaching it logic or math, or how to write code. But then, as the model gets bigger and bigger, something incredible happens. It starts doing things it was never explicitly trained to do. It can suddenly solve complex math problems. It can write computer programs from a simple description. It can even explain jokes or understand metaphors. These skills just emerge. They appear out of the blue once the AI model crosses a certain threshold of size and complexity. It's not a gradual improvement. It's like flipping a switch. One moment it can't do it, and the next, it can. Think of it like water. Individual H2O molecules don't have a property called wetness. You need a massive collection of them before the quality of wetness emerges. In the same way, these advanced AI skills don't exist in the smaller, simpler models. They only show up in the massive, complex ones we are building today, like GPT-4. Scientists are still trying to figure out exactly why this happens. One leading theory is that in order to get really, really good at predicting the next word, the AI has to build an internal model of how the world works. It has to understand cause and effect, logical relationships, and even abstract concepts. It's not just memorizing patterns, it's developing a deeper, more generalized understanding. So when you ask it a math problem, it taps into this hidden world model it built for itself and finds the answer. For example, researchers found that some AI models couldn't do two-digit addition. They kept getting it wrong. But once the model grew past a certain size, its accuracy shot up from near zero to almost 100%. The same thing happened with tasks like translating languages, summarizing articles, and even passing professional exams for lawyers and doctors. These aren't just small tricks, they are genuinely complex cognitive tasks. So what does this mean for our future? On one hand, it's incredibly exciting. We are creating tools that can learn and reason in ways we never directly programmed. This could accelerate scientific discovery, help us solve climate change, and create amazing new forms of art and entertainment. The potential is limitless, but it also raises some big questions. If these abilities can emerge unexpectedly, what other abilities might appear as these models get even bigger and more powerful? It highlights how important it is to be careful and responsible as we develop this technology. We are not just building calculators anymore. We are building systems that are starting to show sparks of something that looks a lot like genuine understanding. The journey into RE's emergent abilities is just beginning. We are explorers in a new digital frontier, and we are discovering things we never thought possible. It's a bit mysterious, a bit scary, but undeniably one of the most important stories of our time. Thanks so much for watching. If you found this as fascinating as I do, hit that like button and subscribe for more deep dives into the future of technology. See you in the next one.